Hello, and welcome back to the PyData track of the Python Web Conference 2021. And with me now is Nisarg Shah, who's joining us from Ahmedabad in India, and he's going to give us a super interesting presentation on GraphQL. So let rest do rest, a deep dive in GraphQL with Django. And with that, over to you, Nisarg.
Hi, thank you very much for introducing me. So my name is Nisarg Shah. I'm from India, and I am a CS undergraduate student in 4th year right now, and I am working as a software developer intern at Fountain 9. And I have worked at a couple of startups, and I have worked as a backend developer intern and have helped them building the great products and all. You can connect me with the following social media links. So what will be the main points which will be covered in this talk? So first of all, I'll start with the APIs. And like what kind of APIs developers have been building, and like what kind of technologies people use to build the APIs, and then we'll shift to understand the concepts of the GraphQL. And then we'll move towards the implementation of the GraphQL, and then we'll see the N+1 issue which is being faced by a lot of developers while building the GraphQL APIs in Django. And then definitely, yeah, we'll see the versioning of the APIs, which is really different from REST. Yeah. So first of all, client-server interaction, right? So I'll talk about a remote procedure call. Now in the remote procedure call, as everyone knows, that a client invokes a procedure and the message is serialized, and the parameters and all the information is pegged into a message, and then it's sent to the server, and the message, message gets the information, and then it gives the result back to the client, right? Obviously, like there is a server stub and the client stub which take care of serializing and the deserializing. But the thing is that building RPC calls are really like straightforward. They are pretty simple. Now, like one issue which I find with the RPC is the security issues, and that is, like, to be more precise, it's tight coupling, that the application layer is being shared with everyone, right? So that's the thing about RPC. Then after that, like many developers have been building their APIs or their applications using the SOAP protocol. So actually SOAP uses an XML formatted message for sending the message from client to server and server to client. It is and it actually has highly standardized web protocols for the communication, right? And like the benefits of using SOAP are like that, there are built-in error handling and the built-in security things and all, right? But like only one thing which like the SOAP has, that like it only supports XML format. It does not support any JSON format or any other format, right? And then the developers shifted to REST for like pretty simple and full development, as REST supports JSON. So like you just need to give a JSON object in the request and bodies and all, and like you can interact, and like the interaction can be done between the client and the server, right? REST actually like like the main benefits and the like on which the REST is built. So it's like REST has a like so like while you are building REST APIs, right, at that time you can cache the APIs very easily, as like you can cache the get API endpoints, right? And also like the APIs are stateless, and like the client server architecture is built on HTTP or HTTPS calls and all, right? The cons about the REST, which they are like, one is the big payloads. When there is an interaction between client and server, like I have seen many developers sending like complete JSON object or like all objects and a huge body, like a huge payload. Now that a huge payload increases your network cost, and like and also like so in a best practice, it's not a better way to pass the complete payload from the backend to the front end, right? And the most important issue in the rest is overfetching and the underfetching. So I'll first talk about the overfetching. So let's say you want a list of uh, username of all the authors, okay, and you got the complete profile of all the authors from the backend. So you got the unnecessary data which you didn't want on the client. You actually wanted only the username, but you got the complete profile. So that's overfetching. That is the data. So you also get the data which you don't require, right? And then like on the front end, you need to pass that JSON and then pick the username and then print that, right? Or like maybe give a follow or something, like any kind of, but like that big payload is also sent from the backend to front end, and also like it's an overfetching issue. The second thing is uh, underfetching. Okay, so let's say you so in underfetching, you actually don't get the complete data which you want on the front end or on the client, right? So let's say you want a list of all the usernames, and along with that you also want some property associated to that which is in some different collection, or let's say some or let's say it's in some different API or something, right? So like to fetch that, you need to call two APIs, or like you need to or like there are such practices where you call like two APIs and then mix and then combine the data, and then client. So it's called fetching. Now the GraphQL. So GraphQL is a query language. So like it's a kind of syntax which describes like how you need the data, and like how precisely you can make a data request to the server, right? So the main benefit of using GraphQL is that it will avoid underfetching and overfetching, and also it will avoid big payloads. The issues with the GraphQL will be that the performance issues and the caching. So if you're using GraphQL API, or like if you're building GraphQL APIs, right, then you'll like while building that you'll face many performance issues, and like you'll see that like many similar kind of SQL queries are being executed for just a single GraphQL query and all. And one thing is caching, as now in GraphQL you'll be having just a single endpoint, so like the caching is a little bit tricky for it. Okay, so now definitely we'll be going to talk about GraphQL. So I have told the benefits that like no overfetching, no underfetching, and it's the main benefit of GraphQL that you get the exact result from the server which you want, and just a single endpoint to call, which means you don't need to require like a list of endpoints like as in REST, like you need to document each and every endpoint, like what it does, and like you don't need to do that right here. You're just a single endpoint which you need to give in the client side. One more benefit would be like if you're building GraphQL APIs, then like auto documentation will be done in Graphene. So I'll show you like how it will look in GraphQL view, but you'll be able to see the APIs. So like they'll be automatically documented for in a GraphQL view, and then like you just need to so like when you finish your commit, like when you finish your code, you can just commit it, and then front-end developers can fetch it, and then they can see like which API you have added, it needs which parameters, and also like what is the uh, response object type which they will get from the server. Okay, and yeah, definitely GraphQL is a really huge community. They are really supportive, and like many solutions are being developed in GraphQL. It's a schema-based system, right? And it's basically a language for querying the databases from the client-side applications. And the main thing is that it really improves client-server interactions by enabling the data by enabling the precise data request, which will obtain no more, no less data, but exactly what you need, right? So before moving further, I'll like to clarify one thing, that nowadays many developers think that GraphQL has replaced REST completely. So it's not the thing. So it's just an alternative to REST. You need to prepare your requirements, at what exactly you need, and according to that you need to decide whether you are going with REST or whether you are going with GraphQL. As REST and GraphQL has their own pros and cons. Like in REST you can cache the queries easily, but in GraphQL it's difficult. In GraphQL you'll face some performance issues, while in REST you can optimize the queries and all, right? So it's not like GraphQL has completely take over REST. It's just an alternative to REST, which you need to decide whether you want to use it or not according to your use case. So it's the most important point which you need to take care of, and just don't start with GraphQL that yeah, it's a trending technology or like it's this and that, but you just need to decide according to your requirements. Okay, so now let's start with GraphQL. First of all, we'll look at a couple of concepts of GraphQL, so you get a better understanding of the base, and then we'll look how we can implement using these concepts and mixing it together and build API. Right? So first of all, I'll show you this schema. So actually, GraphQL is a schema-based query language, right? So like the schema is the most important part in GraphQL. So for schema, so schema is actually, so schema actually defines the object type, and it shows the API. Like in the current schema, you can see that there are fields such as blog ID, author, title, created at, and blog data, right? So these are the fields that are available in the API, and associated with it, which is ID, user type, string, date time, and this string, right? So these are the built-in. So like some are the built-in scalar types. This user type is the scalar type which I have created, and I can also associate it, and I can also associate it with the schema. So actually here the blog is my object type. These are the fields which I can say variables, and these are the scalar types which I can say as data types. Okay, and this exclamation mark, it means that this field is required field. It's a necessary field. Okay, so this is the structure of API. If I'll query the so if I'll use the blog object type, then I'll be able to access this fields, and that fields have the associated data types. Okay, and here's like it's easy to find the usages of a particular types or of particular data types or variables, as you can also track the usages of the schema using some tools, like which schema is being used at max, and like which variables are being fetched very frequently and all. So you can track that using this so in this schema, right? Then query. So query is used for fetching the data from the server. So you can see here, like in my query, so I have one author blogs query. Here it's author blogs query, and there I have passed one username. So actually here I want to fetch all the blogs written by a user named Nisarg, and I want a blog ID title, and I want an author object which should have only ID and username and the blog data. I want only this fields from the server, right? And you can see that the query has the same exact shape as the result, right? So this is the response from the server, and I'm getting the exact required data which I have asked in my query. Okay, and so you can actually design the query according to your needs, and like this really improves the client server interaction, and it helps a lot. Yeah, and we'll see like how to add or edit data in the server. So for that mutations are being used, right? So here I have a mutation named create blog, and there I have passed on the required fields, which is username, title, and blog data. And then I have mentioned which fields I want from the server on the successful successful addition of the blog in the server. So like when a blog is created by using these parameters, I want like blog ID, title, author, username, and blog data, right? So as this mutation query is successfully executed, you can see that this is the response from the server, and I am getting the exact same schema which I have requested from the server. Also, like here, it's not necessary that you just ask for the details of the object which you have added using the mutation. You, for example, by adding a blog, if you want to send a total list of all blogs for all the authors or something else, then you can also do that. Like you just need to define the query structure according to that, and also like from the backend you just you need to send according to that, so you'll be able to match that requirement too. All right, so like this were the three main things which you need to require, and now we'll start with the concepts of the graphene. And yeah, in this implementation I'll be using Django. In the database I have PostgreSQL and graphene library for building the GraphQL APIs. One thing is that graphene library, so in this graphene library, code first approach is used. So what's the code first approach? There are two approaches. One is code first and one is schema first. I prefer, or like I like using code first approach as it's super easy to use, and like I am familiar with it, so like I like it, right? So in code first approach, we actually start by coding the resolvers. What is resolver? I'll cover it in the upcoming presentation. So we'll start by coding the resolvers, and like from that code, an artifact is being generated, and like that artifact is a schema. So so like we first write the code, and on that basis schema is generated. Okay, and in schema first approach, you need to define the schema, and on that schema you actually need to design the APIs, and like that schema needs to be followed by all the team members. Otherwise, like if someone does not follow, then like there might be some breaking chain or something, right? So like due to that, I like code first approach more, as I can directly develop the resolvers, and on the basis of that I get the schema, and it's a proper schema, right? Actually, okay, so yeah, so now we need to look on for a couple of concepts which are used in graphene to develop the APIs in graphene. Okay, so one thing is the object type. So object type is used to define a relation between my fields and between my variables and the schema, right? So as you've seen in, that a schema is a structure, or like it is a definition of my API, which includes all the variables which I can access while using that API, right? So object type actually, so here like each field would be specified as a class attribute, and then it is being mapped in a list or in a field to a variable, and then the data can be fetched by using the resolver function. So here you can see that I have an object. So I have one Django object type, which is, so here this is my class block type, and I'm passing that block type into a list. So like this will be mapped using a list. So the Django object type, which would be converting my Django object into a GraphQL object, and then that I need to map to a variable, and then like using a resolver function of that variable, I can access that API, right? Now I'll talk about the schema. So we need to build a schema, obviously. Now you can build schema by two ways. One is you can explicitly define the variables which you want in your schema, or else you can pass on the complete Django model. So like all the variables of the Django model will be mapped into a GraphQL schema, and like that will become your schema. So I'll show you both the ways. So first of all, I have used, so for mapping the Django object into the GraphQL object, Django object type is being used. So here I have one model named blog, and I want to like convert that, not convert, but actually I want to map all the fields of that models into the GraphQL schema. So I have used Django object type, and here my blogs will be the schema which will have all the fields of the blog. But let's say I want to specify only 4 fields, which is blog ID, title, author, and blog data. Then I need to specify it explicitly, and I need to define their scalar types also, which will be ID, string, and string. Okay. So once, so I can also define the schema by this, like if I want only some variables of that model, right? Resolvers, yeah. So once I have this schema, right, then I need a resolver function which will understand that schema, and then it resolves all the fields of the object type which was mapped into the schema. So yeah, one thing which you need to take care of, that here I have author blogs schema, right? So if I want to resolve this author blogs, then the function of my resolver, so the name of the resolver should be resolve underscore author blogs. So it should be resolve underscore the field name. It's so like this name should be followed, otherwise it won't work. Okay. And now let's talk about the parameters of the resolvers. So it's actually self, info, and quarks. Now actually in the parent, the like root value is set automatically, and then in the info and the quarks, so like in info there is some data about the user authentication if you are implementing, or like some other parameters. And in quarks, so like if you are passing variables in the query, then they will pass in the quarks. So now let's start implementing the GraphQL APIs. So we'll mix all the concepts which we have seen, and you'll be able to connect it dot by dot. Yeah, this is my file structure. So I have a Django project which is blog app, and then I have now one thing is that you need to, so like in this blog app folder, I need to create one schema.py file where I need to map all the schemas and so not schemas, all the mutations and all the queries which I have developed. So this is my schema.py file where I have imported it from the blog.schema, and I have mapped all the queries and all the mutations. So this needs to be taken care of, and I'll be writing my mutations and queries. Okay, my like, so I'll be developing my mutations and queries in this schema.py file which I have created in blog app. And then there is this loaders and context.py file which is being used for n+1 problem, but that I'll show you afterwards, like what's in there. Yeah, this is the GraphQL view, which you'll be able to access it like when you add a URL in urls.py file. So which line to add, I'll show you afterwards. So like here you can write the query. Here you will be able to see the response which you'll get from the server. And yeah, this is the auto documentation which I was talking about. So here is my list of queries. So I have 4 queries: blogs, login, author blogs, and all author blogs. And as you can see that these are the parameters which are required for this specific query, or like this specific API. And this would be the object type which server will send me. So like if you click on the block type, you'll be able to see all the fields which block type has, and then you'll be able to see all the scalar types and everything. So it's really well documented, and you get this auto documented. So it's great, right? So now let's start writing queries, right? So we'll go step by step. So for writing a query, obviously you need one schema. So that I have built. So I have directly mapped the Django object into GraphQL object using the Django object type. So as you can see, this is Django object type, and like I have author blogs. This is my schema or API, what we tell. This author blogs, and I have mapped into a list as I want a list, like right. And then I need to develop a resolver function. So this is my resolver function, and I need to pass the variables here which are required for that specific query. So that variables needs to be passed while mapping the object type into the field, right? And then that username is being passed in the resolver function, and there in this resolver function you write the business logic, and then you can just return the get blocks, but you'll be able to get the data which you have requested from the client. So this is how you write a simple query which will fetch all the blogs written by a particular author, right? Now we'll see how to write a mutation, so how to add a blog. So same, we need to first of all create this schema. I've created it. Here it's create blog, and here I will add the field because like I need to add the so I am actually adding some variables or adding a blog into the server. So like for that graphing.field is used. Yeah, in mutation there is one class named arguments which will have, so like there I we need to define the variables which are required for that particular mutation or for creating that particular object. So for creating the blog I need username, title, and blog underscore data, and that here we need to define the scalar types, which is the string, and record equal to true because I want that like this variables or this field should be required, right? And then in the mutate function you need to pass that variables, and then and here you need to write the business logic where so that's the creating of blog, saving it to blog, and then returning the blog back to the client. It's really simple, right? So yes, you have learned how to like fetch the data from the server, edit the data, create the data, right? So here I have created the blog, but you can also edit the blog or like anything according to it, right? Now we'll talk about the performance issue which you'll face while querying the database, right? So let's see. So here I have one query which will fetch all the authors and all the blogs associated with that authors. Okay. So this is the query for that. Wait, yeah. So all the authors, and then I am getting ID, username, and then the blog object. In that I'm getting blog ID, title, blog data. Right? So when I'll execute this query, it will run. It will be executed successfully, and I'll get the data which I have asked for. Now the issue is like if we'll see the raw SQL queries which are executed behind this query, right? So actually I have installed a debugger in the Graphene which will show me the raw SQL query executed. So this was the result from that. Yeah. So actually it fetched the authors. Yeah, that's great. Cool. And then for fetching the blogs, they like for each and every author, like a new SQL query is being executed. So let's say if I have 500 authors, or if I have 1,000 authors, 10,000 authors, then like you can imagine that like just for a single query, 1,000 SQL queries will be executed in the backend, and it will take a lot amount of time. So this is the main issue. This is the main performance issue which you can solve. And actually, so where's this issue happening? So in the resolver function, where you get that blog.object.all. So there this raw SQL queries are being executed one by one for every author ID, right? So here let's say like I have 2 blogs, right? So in order to get all the required information, I need to send one SQL query for fetching a list of authors, and then 2 additional queries which you can see to fetch the blogs, right? So now what can be done? What can be a potential solution to this problem, right? So Facebook has created data loaders. Now using data loaders, what you can do? You can batch the queries as well as you can cache the queries. Now what does batching means? So batching means that you make a list, or like you batch all the author IDs into a single list, and then pass that single list to the resolvers to resolve the query, and then only one SQL query will be executed. So after implementing the data loader, you can see the raw SQL query which was executed in the backend, which is select star from blog, where blog.author ID in 1,2, which means now that 2 queries has been clubbed into a single query. So like if I have 1,000 queries, then I can club that 1,000 queries into a single query. I can batch those queries. So this would be like really great. It could like improve your performance significantly, and like by implementing this, like you can improve your performance in a great manner, right? So like by batching the queries, this problem can be solved. We'll see the implementation how we can batch. And also data loader gives you the so like it also has the property for caching the queries, but like I prefer to batch the queries, because like for caching the queries, like actually you don't hit the database server right now. Like if you're caching the queries instead of bashing it, right, then like one significant thing which could happen with you is that like if you have changed any let's say any data frequently, or like something has happened in the database, and like you are executing the same query, then you won't be able to hit the database and get the new data. And anyways, like if you are bashing it, then like just 2 SQL queries have been executed, so like it's a really great thing, right? So like for that I have written one loader, right, and then in the schema.py file I have mapped it. So I'll explain what the loader is here. So I am passing the list of author IDs, right, and then I'll filter out all the blocks for a particular author ID which is there in that author ID list, right? So that is blog.objects.filter of author ID in the list of author IDs, and then I'll add that blog into a list. And then after that, so actually what's happening, so it collects a list of keys, and then it calls a batch loading function which accepts the list of keys, and then after that passing that list which promise, and which holds a list of all the values. Okay. uh, so this could solve so by this you can implement the data loader, and it will solve it. One important thing you need to know here is that each data loader instance is created when a request begins, and it's only responsible for batching and caching relative to that single request. So when the request ends, the data loader instance will be thrown in the garbage. And it means that like for let's say I have 500 model DB or 1,000 model DB, right? So like for that I need to create like a lot more data loaders. So like for that I need to develop a significant amount of code. So there's just like one con which I can say about the data loaders, but like rather than that, like it's pretty fascinating, right? And yeah, you need to and like here I am returning that loader, and as you can see here I have cached the property. Like if you want to cache it, then you can cache it, and just add the GraphQL view to the and return the GQL context, so like this context to it. And yeah, this is the path which you need to add for seeing the GraphQL console, right? Now let's we have discussed the performance issue, right? Now let's talk about the versioning. So as you all know that how versioning can be done. So like here I only 2 examples. Like there's a lot more in versioning of REST, but like these are the 2 main techniques which I have seen while I have developed a lot of solution and all. So in REST versioning, so like if you're using URI versioning, then like you give the version v1.0, 1.11.2 or 2.0 at the back of the API endpoint, or like if you are using the query parameters, then you pass it as the query parameters. Although URI versioning is the most popular, and it's used by like most of the developers, but yeah, these are the like 2 main techniques of versioning the REST. Now, talking about the versioning of GraphQL. So there's no such versioning about GraphQL. In GraphQL, the schema evolves. So you change this schema. So as they have a single endpoint, okay, so you just need to call that endpoint. And regarding the schema, regarding the data in that schema, you need to change that data, or like you need to deprecate that data field, or like you need to add that field. So basically, schema evolves. You don't give any version name to that. So here you can see that I want to deprecate this created. So like I don't want to use this created at field furthermore in my APIs. Then I'll just deprecate it, and like I'll write the message. Okay. Um, One more thing which I have seen a lot of users do is actually they divide the schema. So let's say I have like this blog type, okay, and there I have information, blog ID, first name and last name of the author. Now I what I can do is that I'll take that first name and the last name of the author and convert that into a different schema, and then map the author schema into the blog schema, which is done here. Okay, so you can divide this schema by dividing this schema. You can track this schema usages easily, and also like it's easy to manage, right? And the other thing is that which I told, that you can add the deprecated message, and you can add the another fields which you want. So like here, instead of by deprecating the created at, let's say I want to separate the two variables which were being there at the created at, which is created day and time, right? So I can create so I can um, deprecate that field and then add the new fields which I want in the schema. Okay, so this is how like the upper level versioning or the evolution of schema does. uh, there's a lot more there, but like this is the like main basic thing which you'll be able to see when you evolve your schema, right? So yeah, that's it. These are some useful resources like have that. So they have published their blogs about how they have solved the n+1 problem. And yeah, also like for adding authentication and pagination. So like for the authentication, you can simply add some middlewares, and the GraphQL underscore JWT tokens will take care of everything. So like there you'll be able to get 3 mutations, and by using the token auth and the verify token, refresh token, so like that all will be taken care with the middleware which is provided by Graphene. And by using that you can implement it really with an ease. And also if you want to implement pagination, then like you can introduce a couple of variables and then slice the objects, and then you can send whichever is required, right? Yeah, so this is the project link, blog-app, github.com/nisarg1499/blog-app, where you can find this complete code which I have shown in my presentation. And also this is one project which I had done. It's an e-commerce app. So it has a backend of e-commerce app, and it has a couple of cool features. It has JSON web token authentication implemented, pagination implemented, and also a lot of features in there. So maybe you can check it too, right? Yeah. Thank you, everyone. It was pleasure talking at Python Web Conference. Thank you.